molecules, salts, and hydrogen. These ingredients suggest what makes Saturn one of the most fascinating planets in our solar system. Is it the stunning rings that stretch far beyond the planet, or the countless moons that orbit it, each with its own unique story? From mysteries hidden in its atmosphere to the incredible discoveries made by spacecraft, Saturn is a treasure trove of wonders waiting to be explored. Join us as we dive into 10 fascinating facts about Saturn and uncover the secrets of this celestial marvel. Saturn's majestic rings. Saturn's rings are one of the most iconic features in the solar system, captivating astronomers and stargazers alike. Spanning up to 175,000 miles wide, these rings are composed primarily of ice, rock, and dust. Despite their vast size, they are incredibly thin, averaging just 30 feet in thickness. This extraordinary combination of scale and delicacy makes Saturn's rings a true masterpiece of nature. The rings are divided into several sections, with the most prominent ones named A, B, and C. Each section contains countless individual particles ranging from tiny grains to massive chunks of ice. These particles reflect sunlight brilliantly, creating the shimmering effect we see through telescopes. This striking beauty has earned Saturn the nickname, the Jewel of the Solar System. Scientists believe the rings formed relatively recently in cosmic terms, possibly 100 million years ago. They may be the remnants of a shattered moon or comet that was torn apart by Saturn's immense gravity. The ongoing interaction between the planet's moons and its rings creates stunning patterns, including waves and gaps, adding to their dynamic appearance. The Cassini spacecraft provided unprecedented insights into the rings during its mission. By diving through the gaps and analyzing their composition, Cassini revealed intricate details about their structure and origin. The findings not only expanded our understanding of Saturn, but also offered clues about the formation of other planetary ring systems. The rings may not last forever. Over time, they are slowly disintegrating as particles rain down onto Saturn's surface. This fleeting nature adds a poignant layer to their beauty, reminding us of the ever-changing universe we inhabit. The hexagonal storm. At Saturn's North Pole lies a bizarre and mesmerizing phenomenon, a massive hexagon-shaped storm. This geometric wonder was first observed by the Voyager spacecraft in the 1980s and has since been studied extensively by missions like Cassini. Spanning about 20,000 miles across, this storm is large enough to engulf Earth twice over. The hexagon's perfectly symmetrical shape is a result of Saturn's turbulent atmosphere. Scientists believe it forms due to a combination of jet streams and rotational forces unique to the planet. The storm rotates at an astonishing speed, with winds reaching up to 200 miles per hour, creating a spectacle of swirling clouds. Inside the hexagon, a giant hurricane-like storm rages at its center. This storm has a massive eye, nearly 50 times larger than a typical hurricane's eye on Earth. The striking contrast between the central vortex and the surrounding hexagonal structure adds to its otherworldly appearance. One of the most intriguing aspects of the hexagon is its changing colors. During Saturn's long seasons, which last about 7 Earth years each, the storm shifts hues, from a golden yellow to a pale blue. This change is likely due to the interaction between sunlight and atmospheric particles, providing valuable insights into the chemical composition of Saturn's atmosphere. The hexagonal storm remains one of the most mysterious and captivating features of Saturn. Understanding its formation and dynamics could unlock new knowledge about atmospheric phenomena, both on Saturn and other planets, including Earth. Titan, Saturn's largest moon. Titan, Saturn's largest moon, is a world unto itself. Larger than the planet Mercury, Titan has a dense atmosphere and a surface unlike anything else in the solar system. Its thick orange haze, composed mainly of nitrogen and methane, conceals a landscape of rivers, lakes, and seas made of liquid hydrocarbons. This alien world has fascinated scientists since its discovery. Titan's surface temperature is a frigid -290 degrees Fahrenheit, yet its geology bears a striking resemblance to Earth's. Rivers carved by methane rain flow into lakes and seas, creating a hydrological cycle similar to the water cycle on Earth. The Cassini-Huygens mission provided groundbreaking data about Titan. In 2005, the Huygens probe descended through Titan's atmosphere, becoming the first spacecraft to land on a world beyond Earth's moon. It captured images of icy plains, pebble-like structures, and evidence of underground reservoirs of water and ammonia. Titan's potential for life has sparked intense interest. Beneath its icy crust lies a subsurface ocean of liquid water, a key ingredient for life as we know it. The combination of organic molecules in its atmosphere and water below the surface makes Titan a prime candidate for future astrobiological missions. Exploring Titan further could not only reveal the secrets of this moon but also provide clues about the origins of life in the universe. It remains one of Saturn's greatest wonders, a reminder of the diversity and complexity of our solar system. The fastest winds in the solar system. Saturn is home to some of the fastest winds in the solar system, reaching speeds of over 1,100 miles per hour at the equator. These powerful winds are driven by the planet's rapid rotation, which completes a full spin in just 10.7 hours, the shortest day of any planet in the solar system. The winds create striking patterns in Saturn's upper atmosphere, including bands of alternating colors. These bands are composed of ammonia and methane clouds, with the lighter bands rising higher and the darker bands sinking lower. The interplay of these layers forms the planet's iconic striped appearance. Storms frequently erupt in Saturn's atmosphere, further showcasing the planet's volatile weather. One of the most famous is the Great White Spot, a massive storm that appears roughly every 30 Earth years. These storms can grow large enough to encircle the entire planet, leaving visible scars on its surface. The winds also play a crucial role in distributing heat across Saturn. Despite being nearly 900 million miles from the Sun, the planet radiates more heat than it receives. Scientists believe this heat comes from its interior, where helium rain generates energy that fuels the extreme winds and storms. Studying Saturn's winds provides valuable insights into the dynamics of planetary atmospheres. It helps scientists understand weather patterns on gas giants and their smaller cousins, the exoplanets orbiting distant stars. Saturn's winds remain a fascinating example of the raw power of nature. Saturn's gravity and low density. Saturn is a planet of extremes, and its gravity is no exception. Despite being the second largest planet in the solar system, Saturn's gravity is only slightly stronger than Earth's due to its low density. Saturn is so light that it could float in water, assuming you could find an ocean large enough to hold it. The planet's density is less than 1/10 that of Earth, primarily because it is composed mostly of hydrogen and helium, the lightest elements in the universe. This unique property gives Saturn its characteristic shape, a slightly flattened sphere due to the centrifugal force generated by its rapid rotation. Gravity plays a crucial role in shaping Saturn's moons and rings. The planet's immense gravitational pull has captured dozens of moons and influenced their orbits over billions of years. Saturn's rings also owe their dynamic structure to gravity, with moonlets within the rings creating gaps and waves that add to their striking appearance. Scientists have studied how Saturn's gravity interacts with its moons to understand tidal forces. For example, these forces create tidal heating in moons like Enceladus, causing geological activity such as geysers. This phenomenon demonstrates how gravity can shape the geological and atmospheric features of celestial bodies. The study of Saturn's gravity provides valuable insights into planetary formation and evolution. It also helps us understand how gas giants develop their unique characteristics, adding another layer of intrigue to this magnificent planet. Enceladus, the ocean world. Enceladus, one of Saturn's smaller moons, is a tiny world with a big secret. Beneath its icy surface lies a global ocean of liquid water, making it one of the most promising places to search for life beyond Earth. This discovery has transformed Enceladus into a focal point of astrobiological research. The moon's surface is covered in a thick layer of ice, which reflects nearly all sunlight, giving it a dazzling white appearance. At its south pole, geysers shoot plumes of water vapor and icy particles hundreds of miles into space. These plumes are evidence of the subsurface ocean and have been a treasure trove for scientists studying the moon's potential for life. The Cassini spacecraft made groundbreaking discoveries about these plumes, detecting organic molecules, salts, and hydrogen. These ingredients suggest that hydrothermal vents at the ocean floor could provide the necessary conditions for microbial life, similar to those found in Earth's deep oceans. Enceladus's geysers also contribute material to Saturn's E-ring, one of its faint outer rings. This connection between the Moon and the planet highlights the dynamic interplay of celestial bodies within the Saturnian system. Exploring Enceladus further is a top priority for future missions. By studying its ocean and geysers in greater detail, scientists hope to uncover whether life exists in this distant, icy world. Enceladus is a reminder that even the smallest moons can hold the greatest mysteries. Saturn's magnetic field. Saturn's magnetic field is one of the most powerful in the solar system, second only to Jupiter's. Generated by the movement of metallic hydrogen within the planet's core, this magnetic field creates a protective bubble around Saturn known as a magnetosphere. The magnetosphere extends far into space, trapping charged particles and shielding the planet and its moons from harmful solar wind. This protective barrier also plays a role in creating Saturn's stunning auroras, which light up the polar regions in dazzling displays of ultraviolet light. Saturn's magnetic field is unique in its near-perfect alignment with the planet's rotational axis. This unusual feature has puzzled scientists, as it defies current theories of how magnetic fields are generated. The study of Saturn's magnetism could provide new insights into the internal dynamics of gas giants. The interaction between the magnetic field and Saturn's rings creates fascinating phenomena. For example, charged particles from the rings can influence the structure of the magnetosphere, while the magnetic field, in turn, affects the behavior of the rings. This dynamic relationship offers a glimpse into the complex interplay of forces shaping the Saturnian system. Understanding Saturn's magnetic field is not only key to unraveling the mysteries of the planet itself, but also to comprehend the broader mechanisms governing planetary magnetism in the universe. The seasons of Saturn. Saturn's tilt of 26.7 degrees gives the planet distinct seasons, similar to those on Earth. However, because Saturn takes nearly 29.5 Earth years to complete one orbit around the Sun, each season lasts more than 7 Earth years, creating long and dramatic transitions. During its summer and winter solstices, the planet's poles are bathed in continuous sunlight or shrouded in darkness, creating stark contrasts. These prolonged periods of light and shadow affect the behavior of Saturn's atmosphere, with storms and cloud formations changing in response to seasonal shifts. The rings also reflect these seasonal changes, appearing brighter or dimmer depending on the angle of sunlight. During equinoxes, when the sun shines edge onto the rings, they cast thin shadows on the planet's surface, creating breathtaking sights captured by spacecraft like Cassini. Seasonal variations extend to Saturn's moons, particularly Titan. Methane lakes on Titan's surface change in size as the seasons progress, offering a glimpse into the moon's unique weather cycle. These observations provide valuable data about how Saturn's environment evolves over time. Studying Saturn's seasons helps scientists understand the effects of axial tilt and orbital dynamics on planetary systems. It also highlights the intricate connections between the planet, its atmosphere, and its moons, painting a vivid picture of a world in constant motion. Saturn's core and internal heat. Deep within Saturn lies a mysterious core that has long intrigued scientists. Unlike the solid cores of rocky planets like Earth, Saturn's core is likely a mixture of rock, metal, and ice surrounded by a dense layer of metallic hydrogen. This unique composition is the result of the planet's immense pressure and low temperature, creating conditions unlike anything we experience on Earth. The core is estimated to be about 10 to 20 times the mass of Earth, but its exact size and composition remain uncertain. This uncertainty stems from the difficulty of observing a region buried beneath thousands of miles of dense gas. However, data from the Cassini spacecraft has provided clues, suggesting that the core may be more diffuse and less defined than previously thought. Saturn generates more heat than it receives from the Sun, a phenomenon linked to its core. Scientists believe this heat comes from helium rain within the planet. As helium droplets form in Saturn's upper atmosphere, they sink toward the core, releasing gravitational energy as heat. This process is a key driver of the planet's internal energy and contributes to its dynamic weather patterns. The heat from the core also affects Saturn's atmosphere, influencing the formation of storms and the movement of wind currents. It provides a stark contrast to the planet's frigid outer layers, where temperatures can drop as low as -288 degrees Fahrenheit. This interplay of heat and cold creates the unique atmospheric dynamics observed on Saturn. Understanding Saturn's core is essential to unraveling the secrets of giant planets. By studying its structure and energy sources, scientists can learn more about the processes that shaped not only Saturn, but also other gas giants and exoplanets in distant star systems. Saturn's role in shaping the solar system. Saturn is not just a celestial marvel, it plays a significant role in the architecture of our solar system. As one of the most massive planets, its gravitational pull has a profound impact on the orbits of nearby celestial bodies, shaping the paths of asteroids, comets, and even its own moons. The planet's gravitational influence is believed to have helped stabilize the solar system during its early formation. By capturing and redirecting stray objects, Saturn likely prevented many collisions that could have disrupted the development of the inner planets, including Earth. This protective role has earned Saturn the nickname of a cosmic guardian. Saturn's interaction with its moons adds another layer of complexity. Tidal forces between the planet and its moons, such as Enceladus and Titan, drive geological and atmospheric activity. These interactions not only shape the moons themselves, but also contribute material to Saturn's rings, creating a dynamic system of mutual influence. The planet's position in the solar system also affects the Kuiper belt and the Oort cloud, regions filled with icy objects at the outer edges of the Sun's influence. Saturn's gravity, combined with that of Jupiter, helps steer comets toward the inner solar system, where they can be studied in greater detail. These icy visitors often provide valuable information about the early solar system and the building blocks of life. By studying Saturn's role within the solar system, scientists gain a deeper appreciation for how planets interact with one another and their surroundings. Saturn's gravitational dance is a reminder of the intricate and interconnected nature of our cosmic neighborhood, highlighting the planet's enduring significance in the grand scheme of the universe. Saturn is more than just a planet. It's a cosmic masterpiece filled with wonders that stretch the boundaries of our imagination. From its majestic rings to its mysterious moons and dynamic storms, Saturn continues to inspire awe and curiosity. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the universe with us. Ever wondered what makes Venus one of the most fascinating planets in our solar system? From its mysterious backward spin to its surface temperatures that could melt lead, Venus is a world of extremes and surprises. Did you know it's considered both Earth's twin and a potential warning about our planet's future? Join us as we uncover 10 mind-blowing facts about Venus, exploring the secrets of this enigmatic world and what it tells us about our place in the cosmos. Venus rotates backward, a planet in reverse. Venus does something truly unusual. It spins backward compared to most planets in the solar system. While Earth rotates on its axis from west to east, Venus spins from east to west. This retrograde rotation means the Sun rises in the west and sets in the east on Venus, a concept that's hard to imagine for those of us used to Earth's patterns. The reasons for this backward spin remain a cosmic mystery. Scientists theorize that a massive collision with an asteroid or protoplanet during Venus's formation may have flipped its axis. Another possibility is the influence of gravitational forces from the Sun and other planets, gradually altering its spin over billions of years. What's even more fascinating is that a day on Venus is longer than a year on Venus. It takes about 243 Earth days for Venus to complete one rotation on its axis, but only 225 Earth days to orbit the Sun. This creates a bizarre dynamic where the planet's surface experiences incredibly long periods of daylight and darkness, leading to extreme environmental conditions. Venus's slow and backward rotation contributes to its thick, stagnant atmosphere, as the planet lacks the Coriolis effect that creates dynamic weather patterns on Earth. This strange spin offers clues about the chaotic early days of planetary formation and how celestial collisions can shape a world's destiny. Venus is the hottest planet in the solar system. Despite being the second planet from the Sun, Venus is the hottest planet in our solar system. its surface temperatures reach a staggering 900 degrees Fahrenheit, hot enough to melt lead. This intense heat is caused by a runaway greenhouse effect, where Venus's thick atmosphere traps solar energy and keeps the planet perpetually scorching. The atmosphere of Venus is primarily composed of carbon dioxide, with clouds of sulfuric acid reflecting sunlight. Instead of cooling the planet, this creates a heat-trapping cycle that has turned Venus into an inferno. Even spacecraft that have landed on Venus could only survive for a few hours before succumbing to the extreme temperatures and crushing pressures. What's intriguing is that Venus may have once been much cooler and possibly even supported liquid water on its surface. Some researchers suggest that billions of years ago, Venus might have been Earth-like, with conditions that could have supported life. However, as the planet's greenhouse effect intensified, its oceans boiled away, leaving the barren, hostile world we see today. Venus serves as a stark reminder of the power of greenhouse gases and the potential consequences of climate change. By studying Venus, scientists hope to gain insights into Earth's atmospheric dynamics and how to prevent a similar fate on our planet. Venus has super-rotating winds. Beneath its serene appearance, Venus is home to some of the most extreme weather conditions in the solar system. The planet's thick atmosphere is whipped into a frenzy by super-rotating winds that reach speeds of up to 250 miles per hour. These winds circle the planet in just 4 Earth days, far outpacing Venus's sluggish rotation. The phenomenon of super-rotation is not fully understood, but scientists believe it's driven by a combination of solar heating, the planet's dense atmosphere, and its slow rotation. The winds are strongest in the upper atmosphere, creating a high-speed jet stream that encircles the planet. Near the surface, however, the winds slow down significantly, creating a much calmer environment. These winds also drive the movement of Venus's thick cloud layers, which are composed of sulfuric acid droplets. The clouds reflect sunlight, giving Venus its bright and shining appearance in the night sky. This reflection is why Venus is often called the morning star or evening star, as it's one of the brightest objects visible from Earth. Venus's super-rotating winds challenge our understanding of atmospheric dynamics and highlight how different a planet's weather systems can be from those on Earth. Studying these winds could provide insights into atmospheric phenomena on other planets and even exoplanets beyond our solar system. Venus has no magnetic field. Unlike Earth, Venus lacks a significant magnetic field, leaving it exposed to the full force of solar wind and radiation. Magnetic fields are usually generated by a planet's molten core and its rotation, but Venus's slow spin and internal structure prevent it from producing this protective shield. Without a magnetic field, Venus's atmosphere interacts directly with the solar wind, leading to the gradual loss of lighter elements like hydrogen. This loss likely contributed to the disappearance of water on Venus, as solar radiation broke water molecules into hydrogen and oxygen, with hydrogen escaping into space. The lack of a magnetic field has also made Venus a prime target for studying how planets interact with their star. By observing Venus, scientists can learn more about the effects of solar wind on a planet's atmosphere and the conditions that could affect habitability in other worlds. Interestingly, Venus's atmosphere is so thick that it still retains most of its gases despite the absence of a magnetic field. This resilience provides a stark contrast to Mars, which also lacks a magnetic field but has a much thinner atmosphere. The differences between Venus, Earth, and Mars highlight the complex interplay of factors that shape a planet's evolution. Venus's surface is a volcanic landscape. The surface of Venus is dominated by volcanic features, making it one of the most geologically active planets in the solar system. Over 80% of Venus's surface is covered in volcanic plains, with vast lava flows, towering mountains, and massive calderas. Venus is home to some of the largest volcanoes in the solar system, including Mont Mons, which rises nearly 5 miles above the surrounding plains. Unlike Earth, where volcanic activity is driven by tectonic plate movements, Venus's volcanism is thought to result from upwelling plumes of molten rock beneath its crust. Recent studies suggest that Venus may still be volcanically active today. Observations from spacecraft have detected changes in the planet's surface temperature and composition, hinting at ongoing eruptions. This activity could be responsible for the sulfur dioxide variations observed in Venus's atmosphere. The volcanic landscape of Venus offers a window into the planet's geologic history and provides clues about its internal structure. By studying Venus's volcanoes, scientists hope to better understand the role of volcanism in shaping planetary surfaces and atmospheres. Venus's fiery surface is both a testament to its violent past and a reminder of the dynamic processes that continue to shape our solar system. Venus's atmosphere is a crushing hellscape. The atmosphere of Venus is a place of unimaginable extremes, making it one of the most hostile environments in the solar system. Composed primarily of carbon dioxide with traces of nitrogen and sulfur dioxide, this thick atmosphere creates pressures 92 times greater than Earth's at the surface. It's equivalent to being nearly a mile underwater on Earth. The crushing pressure isn't the only challenge. The atmosphere contains clouds of sulfuric acid that blanket the planet, reflecting sunlight and giving Venus its bright appearance. These clouds not only make it impossible to see the surface from space, but also contribute to the planet's searing heat. Despite these extreme conditions, scientists are fascinated by Venus's atmosphere. Some studies suggest that microbial life could exist in the upper cloud layers, where temperatures and pressures are more Earth-like. This possibility has sparked interest in sending more missions to explore the atmosphere and uncover its secrets. Understanding Venus's atmosphere is crucial for planetary science, as it provides a glimpse into what happens when a greenhouse effect goes unchecked. By studying Venus, we gain insights into climate dynamics that could have implications for Earth and other planets. The atmospheric hellscape of Venus is both a warning and a wonder, showcasing the planet's ability to challenge our expectations about what a world can be. Venus once had oceans, but they boiled away. Venus may seem like an inferno now, but evidence suggests that it once had oceans of liquid water. Billions of years ago, Venus's conditions might have been similar to Earth's, with a cooler surface and the potential to support life. As the sun gradually brightened over time, Venus's temperatures rose, causing its oceans to evaporate. The water vapor, a potent greenhouse gas, traps more heat in the atmosphere, creating a runaway greenhouse effect. This led to the boiling away of its oceans and the transformation of Venus into the scorched planet we see today. One of the key pieces of evidence for past water on Venus comes from the ratio of deuterium to hydrogen in its atmosphere. Deuterium, a heavier isotope of hydrogen, is more likely to remain in the atmosphere when water is lost. Venus's atmosphere has a much higher deuterium to hydrogen ratio than Earth's, suggesting significant water loss. Understanding Venus's climatic history is vital for modeling the evolution of habitable environments. If Venus had liquid water and potentially habitable conditions, why did it change so drastically? These questions drive ongoing research and missions aimed at uncovering the planet's past. The story of Venus's lost oceans is a haunting reminder of how fragile habitable conditions can be and how planetary environments can evolve over time. Venus's surface is young and renewed. Unlike the Moon or Mars, which are littered with craters from billions of years of impact, Venus's surface is relatively young, with an average age of about 300 to 500 million years. This youthfulness suggests that the planet undergoes periodic resurfacing events that erase its geological history. The primary mechanism for this resurfacing is thought to be volcanic activity. With no tectonic plates like Earth, Venus's crust may periodically heat up and melt, leading to massive lava flows that cover the surface. This process essentially resets the planet's geological clock, making Venus a dynamic but enigmatic world. Radar mapping from missions like NASA's Magellan spacecraft has revealed a surface covered in vast plains, mountain ranges, and unique features called coronae, which are formed by upwelling plumes of molten rock. These features indicate that Venus's geology is driven by internal processes rather than external impacts. The lack of tectonic plates also means that Venus doesn't have the same mechanisms for recycling carbon as Earth. This contributes to its runaway greenhouse effect, as carbon dioxide remains locked in the atmosphere instead of being absorbed into the crust. Venus's young surface tells a story of continuous renewal, highlighting how volcanic activity can shape a planet in ways that are both similar to and vastly different from Earth. Venus shines brightest in the sky. Venus is often called the morning star or evening star because of its dazzling brightness in the sky. It's the third brightest natural object visible from Earth, after the Sun and the Moon. This brilliance has made Venus a prominent feature in human culture and mythology for thousands of years. The planet's brightness is due to its thick clouds, which reflect about 70% of the sunlight that hits it. Combined with its proximity to Earth, this makes Venus appear incredibly luminous, even to the naked eye. Ancient civilizations often associated Venus with gods and goddesses of love and beauty, like Aphrodite in Greek mythology and Ishtar in Mesopotamian traditions. Astronomically, Venus follows an interesting pattern in the sky. It's visible either just before sunrise or just after sunset, depending on its position in its orbit. Because it stays close to the sun from our perspective, Venus never ventures far into the night sky, adding to its mystique. This brightness also makes Venus an ideal target for telescopes and spacecraft. Its visibility has inspired countless missions to explore its secrets, from early flybys to ambitious plans for future atmospheric studies. Venus's brilliance reminds us of its enduring presence in our skies, captivating humans for generations and fueling our curiosity about the universe. Venus may hold clues to Earth's future. Venus is often called Earth's twin because of their similar size, composition, and proximity to the Sun. However, the stark differences between the two planets make Venus an essential case study for understanding Earth's potential future. The runaway greenhouse effect on Venus offers a sobering example of what could happen if a planet's atmosphere becomes overwhelmed by heat-trapping gases. As Earth grapples with climate change, studying Venus provides valuable insights into the dynamics of atmospheric warming and the delicate balance needed to maintain habitable conditions. Venus also highlights the role of geological processes in shaping a planet's destiny. With no plate tectonics or magnetic field, Venus lacks the mechanisms that help regulate Earth's environment. This contrast underscores the importance of these systems for maintaining a stable climate and supporting life. By sending missions to Venus, scientists hope to unlock its secrets and learn how two similar planets ended up on such divergent paths. Future explorations like NASA's Veritas and Da Vinci missions aim to study Venus's atmosphere, surface, and geological history in unprecedented detail. The story of Venus is not just about understanding another planet, it's about understanding our own. By comparing Earth and Venus, we gain a deeper appreciation for the factors that make our world unique and the steps we must take to protect it. That wraps up our exploration of Venus, a planet of extremes, mysteries, and profound lessons for Earth. From its scorching surface to its haunting past, Venus challenges us to rethink what we know about the cosmos. If you enjoyed this journey, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us. Have you ever gazed up at the night sky and wondered what bizarre, otherworldly places might be out there? The universe is filled with exoplanets so strange and extreme that they defy imagination. From planets hotter than stars to worlds made entirely of ice, these discoveries redefine what we thought was possible. Join us as we take a journey to explore the 10 strangest exoplanets discovered so far. Each one will blow your mind, so stick around and let's dive into the cosmos together. Kelt 9b, a scorching inferno. Meet Kelt 9b, a planet so blisteringly hot it challenges the boundaries of planetary science. Orbiting a star twice as hot as our Sun, this gas giant experiences daytime temperatures exceeding 7,800 degrees Fahrenheit. That's hotter than some stars. The extreme heat has stripped the planet of its atmosphere's molecules, breaking them down into their basic atomic components. This planet orbits so close to its host star that a year lasts only about 1.5 days. Its proximity causes it to be tidally locked, meaning one side is perpetually facing the scorching star while the other remains in darkness. Scientists speculate that the night side might be slightly cooler, but cooler is relative when the entire planet is engulfed in unrelenting heat. What makes Kelt 9b even more extraordinary is that it's gradually evaporating. The intense radiation from its star is blowing its atmosphere away into space, creating a glowing tail, much like a comet. This phenomenon provides astronomers a rare glimpse into atmospheric escape, a process that's reshaping our understanding of planetary evolution. Traveling to Kelt 9b isn't an option, it's inhospitable beyond imagination, but studying it reveals how diverse and extreme planets in our universe can be. It's a fiery example of how exoplanets push the limits of what we consider possible in the cosmos. Gliese 436 billion, the ice on fire world. Gliese 436b seems like a contradiction of nature. Imagine a planet covered in burning ice. Located about 30 light-years away, this Neptune-sized world defies expectations with its bizarre mix of heat and ice. Its surface temperature is a scorching 800 degrees Fahrenheit, yet water exists as a solid ice mantle, compressed by the planet's immense gravity. This scorching world has a thin atmosphere, primarily composed of hydrogen, helium, and methane, which traps heat. Despite the intense temperatures, the high pressure on the planet keeps water locked in a strange, solid state called hot ice. This exotic form of water remains stable even under extreme heat, an incredible reminder of how physics behaves differently in alien worlds. Adding to the intrigue, Gliese 436b completes an orbit around its host star in just 2.6 Earth days. This tight orbit means the planet is exposed to constant stellar radiation, which further accentuates the paradox of its fiery, ice-covered surface. This otherworldly discovery shows how diverse exoplanets can be, challenging our understanding of what's scientifically possible. Gliese 436b is a testament to the universe's endless creativity, blending fire and ice in a way that can only exist far beyond our solar system. HD 189,733b, the glass rain planet. Known as Osiris, HD 209458b is a gas giant slowly being ripped apart by its parent star. Located 150 light-years away, this exoplanet is losing its atmosphere to space at an astonishing rate due to its proximity to its host star. It's a perfect example of a hot Jupiter, a gas giant orbiting extremely close to its star. Osiris experiences extreme ultraviolet radiation that heats its atmosphere, causing hydrogen and helium to escape into space. This process forms a massive tail of gas trailing behind the planet, making it resemble a comet more than a traditional planet. This tail stretches thousands of miles and offers a fascinating glimpse into planetary disintegration. Astronomers have even detected heavier elements like oxygen and carbon in the escaping atmosphere. This discovery is groundbreaking, as it allows scientists to analyze the chemical composition of an exoplanet's atmosphere in detail. The fate of Osiris provides an eerie glimpse into the potential endgame for other exoplanets orbiting too close to their stars. It's a powerful reminder of the delicate balance planets must maintain to survive the harsh realities of space. Kepler 16b, the Tatooine planet. Kepler 16b is a real-life version of Tatooine from Star Wars, a planet that orbits not one but two stars. This celestial oddity is located about 200 light-years away and is a gas giant roughly the size of Saturn. Its dual suns create a surreal, ever-changing skyline that alternates between single and double sunsets. The planet lies in a circumbinary orbit, meaning it revolves around both stars as they dance together in a cosmic waltz. Despite its dramatic skies, Kepler 16b is surprisingly cold, with temperatures averaging around -100 degrees Fahrenheit. This chill is due to the distance from its host stars, which provide just enough light to illuminate its surface without warming it significantly. Kepler 16b's discovery confirmed that planets can form and survive in binary star systems, a finding that expands the possibilities for where planets might exist in the universe. This revelation has inspired scientists to explore the dynamics of binary systems further, opening the door to more discoveries in the future. Though uninhabitable, Kepler 16b sparks the imagination with its resemblance to science fiction worlds. Its existence proves that the universe holds surprises beyond anything we could dream up in fiction. 55 Cancri E, the lava world. 55 Cancri E is a planet of extremes. Found 41 light-years away in the Cancer constellation, this rocky super-Earth is locked in a perpetual furnace. With one side permanently facing its star, the planet experiences temperatures soaring over 4,400 degrees Fahrenheit. On the other side, where starlight never reaches, temperatures plummet drastically, creating a world of stark contrasts. This hellish planet is theorized to have rivers of lava flowing on its day side. Its surface glows with molten rock, illuminated by its blistering star. Scientists also suspect that the planet's atmosphere is dense with vaporized minerals, adding to its fiery ambience. The interaction between the extreme heat and the planet's unique geology creates an environment where lava oceans could exist, constantly churning and reshaping the surface. What makes 55 Cancri e even more captivating is its unusual orbit. A year on this planet lasts only 18 Earth hours, meaning it hurtles around its star at breakneck speeds. The extreme proximity to its host star also causes significant tidal heating, contributing to its molten state and making it an active and volatile world. As bizarre as 55 Cancri e sounds, its study offers scientists valuable insights into planetary formation under extreme conditions. This lava world is a testament to how planets can evolve into scorching wastelands that challenge our perceptions of habitability. WASP 12b, the planet being consumed. WASP 12b is a doomed world, slowly being devoured by its host star. Located about 1,400 light-years away, this gas giant orbits perilously close to its star, completing an orbit in just over 1 Earth day. Its proximity subjects the planet to immense gravitational and radiation forces, causing its atmosphere to stretch and form an elongated shape rather than the typical spherical form of planets. The intense radiation from the star heats WASP 12b to temperatures around 4,000 degrees Fahrenheit, making it one of the hottest known exoplanets. This heat has caused the planet's outer layers to expand and leak into space, forming a trail of escaping gases. Essentially, WASP 12b is being consumed alive, losing about 189 quadrillion tons of material every year. Astronomers studying this phenomenon have likened it to a celestial version of vampirism, where the host star is draining the planet of its lifeblood. Over time, this will result in WASP 12b being entirely obliterated, leaving nothing but a ghostly ring of debris around the star. This dramatic process offers a rare glimpse into planetary destruction, a stage in the life cycle of planets that's difficult to observe directly. WASP 12b's tragic fate reminds us of the fragile balance planets must maintain to survive the harsh realities of space. TRES 2b, the darkest planet. TRES 2b, located about 750 light-years from Earth, is often called the Black Planet due to its astonishing ability to absorb light. This gas giant reflects less than 1% of the starlight that hits it, making it darker than coal. Despite being bathed in the light of its host star, the planet remains eerily dark, with only a faint red glow caused by its internal heat. The reason for TRES 2b's darkness lies in its unusual atmosphere, which lacks reflective clouds and is rich in light-absorbing chemicals like titanium oxide. These compounds trap heat and light, giving the planet its pitch-black appearance. The lack of an atmosphere capable of scattering light further enhances its shadowy nature. Although it's cloaked in darkness, TRES 2b is incredibly hot, with temperatures soaring to over 1,800 degrees Fahrenheit. The stark contrast between its searing heat and its inky blackness makes it one of the most intriguing exoplanets ever discovered. Scientists are still unraveling the mystery of why TRES 2b is so exceptionally dark. Studying it could provide insights into atmospheric compositions and help identify similar worlds in the future. TRES 2b is a haunting reminder of how alien and diverse planets beyond our solar system can be. PSR B16 2026b, Methuselah, the ancient planet. Nicknamed Methuselah for its incredible age, PSR B 162026b is the oldest known planet in the universe, with an estimated age of 12.7 billion years. That's nearly 3 times the age of Earth. Orbiting a binary system composed of a pulsar and a white dwarf, Methuselah is located in the globular cluster M4, about 12,400 light-years away. This gas giant challenges everything we know about planetary formation, as it emerged when the universe was less than 1 billion years old and lacked many of the heavier elements needed to form planets. Its existence suggests that planets can form under a broader range of conditions than previously thought. Methuselah's orbit around its host stars is both stable and extraordinary, taking about 100 Earth years to complete. This leisurely pace offers scientists a fascinating opportunity to study the gravitational interactions within its unique binary system. Despite its ancient origins, Methuselah is a robust planet that has endured countless cosmic events, including nearby supernovae and the gradual aging of its host stars. It's a true survivor, offering a window into the universe's earliest days. HD 189733b, the glass rain planet. HD 189733b, a stunningly violent world, is located 64 light-years away in the constellation Vulpecula. This gas giant has an atmosphere dominated by silicate particles, which condense to form clouds of molten glass. The result is a planet where it literally rains glass, blown sideways by winds exceeding 5,400 miles per hour. The planet's deep blue hue, similar to Earth's oceans, is caused by the scattering light of these silicate particles. However, the similarities to Earth end there. With surface temperatures reaching a scorching 1,700 degrees Fahrenheit, HD 189733b is a hostile and volatile world. The extreme winds and glass rain are driven by the planet's tight orbit around its host star, which is completed in just over 2 Earth days. This proximity subjects it to intense radiation and tidal forces, fueling its chaotic weather patterns. HD 189733b is a prime example of how alien and extreme weather can get on exoplanets. Studying this world offers scientists clues about atmospheric dynamics and helps refine techniques for detecting similar phenomena on distant planets. Ogle 2005 BLG 390lb, the coldest planet. Ogle 2005 BLG 390lb, located a staggering 21,500 light-years away, is one of the coldest exoplanets ever discovered. Dubbed the Hoth planet after the icy world in Star Wars, this frozen super-Earth exists in the far reaches of its host star's habitable zone. With surface temperatures plummeting to minus 370 degrees Fahrenheit, it's a desolate, icy wasteland. This frigid planet orbits a faint red dwarf star, which provides little heat and light. The planet's vast distance from its star results in an extremely long orbital period, taking about 10 Earth years to complete one revolution. Despite its cold environment, Ogle 2005 BLG 390lb's discovery was groundbreaking, as it was one of the first planets detected using gravitational microlensing. Its icy surface suggests that it could potentially harbor frozen water, sparking curiosity about its composition and the possibility of life beneath its frozen crust. While unlikely to be habitable, studying Ogle 2005 BLG 390lb has expanded our understanding of where planets can exist and thrive. This frozen world highlights the incredible range of environments exoplanets can offer, proving that even the most inhospitable conditions can yield fascinating discoveries. And there you have it, the 10 strangest exoplanets discovered so far. Each of these alien worlds challenges our understanding of the universe and expands our imagination. If you enjoyed this cosmic journey, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the extraordinary wonders of space. What makes Saturn one of the most fascinating planets in our solar system? Is it the stunning rings that stretch far beyond the planet, or the countless moons that orbit it, each with its own unique story? From mysteries hidden in its